So we are continuing on with chapter 11, 11.3. We're measuring angles inside and outside the circle. These angles do not have to happen at the center like central angles did. They do not have to happen on the circle like inscribed angles did. These are going to be angles kind of anywhere, as you'll see in this next slide. Notice that these angles are occurring inside, but this is not at the center, and this is not at the center. All right, so and one thing I wanted to go over, because I don't think I did this, so you might want to star this. This is something I should have done with the book. The book didn't really talk too much about it, but if you have a circle and you have the center of it, and the center is A, then that is called circle A. Let me align my board real quick. So that's how you name a circle, by the way, real quick, is just you name it by the center. So if I was going to name any of these, I wouldn't know what to name them necessarily because C and N are not the center. All right, so here we go. So interior angle of a circle theorem says, if an angle is formed by two intersecting chords or secants of a circle such that the vertex of the angle is interior, inside the circle, then the measure of the angle is half the sum of the measure of the arcs intercepted by its angles and vertical angles. So here's what it is. If you see this angle right here, and I am looking for angle A, C, B. I'm looking for this angle right here. I want to know what that is. It is half. It is equal to 1/2 of, and it says the sum. Sum means addition. So you're going to take this arc right here. That's one of the intersecting arcs. And this arc right here, you're going to add those together. So you're getting 140 plus 40. Add those together and take half of that. So you get 180. Half of that is 90 degrees. So that would be a 90-degree angle. All right, same thing with this one over here. You're going to take, and this, the only difference between this is these are chords. These are secants. So you've got, if I want to find angle ONP, it would equal 1/2 of 125 plus 35 equal 1/2 of 160, which would be 80 degrees. Now, this would be 80 degrees, but hopefully you still remember from old, this would be 80 degrees because those are called vertical angles. This would then have to be 100 degrees because of these guys being a linear pair having to be 180, and this would also be 100 because of this being vertical. So all those vertical angles, linear pair things are still going to happen because we're dealing with a line right here. We're dealing with another line. These are vertical, so they're congruent. These are vertical because they're congruent. These guys right here are a linear pair because they make a straight line. So don't forget all that old stuff, just reviewing it to make sure we got it. Exterior angles of the circle kind of says the similar thing, except this time you're going to take these two angles right here and you are going to subtract them. Now I gave you 3 cases because I wanted to show you the 3. On the exterior, you got 3 different cases that can happen. This case 1 is where you have 2 secants. I'm sorry, you have a secant and you have a tangent. Notice it's tangent because it's just barely touching at 1 point. This one is a secant because it's touching at 2 points. And remember, it's going to be very similar. You're just going to take these 2 angles, or these 2 arcs right here, and subtract them. So obviously you take this major arc right there and subtract that minor arc. You're always going to take the bigger one and subtract the smaller one. So over here, we've got 2 secants, and the reason I know that there's 2 secants is because intersects once, twice, intersects once, intersects twice, and I would take this arc, and I would subtract this, and again, it's still going to be half of that. So it's going to be half of that. And then over here, lastly, so this was a secant, and this was a secant, you have a tangent and a tangent. The tangent one are the ones that are a little tricky. Just remember, if you think about this arc right here, and this arc right here would have to equal the whole thing because that tangent line just touches it. And when I mean the whole thing, I mean they'd have to add up to be 360 degrees because that would be the full circle. And again, to get the measure of this angle right here, you would take this, subtract this, and take 1/2 of it. For this one right here, you would take this and subtract this, take 1/2 of it. For this angle in here, you would take this, subtract this, and 1/2 of it. And again, the same thing is happening. We've got linear pairs going on, vertical angles going on, linear pairs. So hopefully you can see my dots. This and this are linear pair, this and this are vertical. Review, vertical, those guys are congruent to each other, as well as this one's congruent to that over there. And then the 1 arc and the 2 arc, those guys have to add up to 180. Alright, so getting through this, if they ask us to find, so they say, what is the measure of angle BAD? Bad. So bad, that would be this angle right here. Hopefully that's not going to be your test grades. That would be this angle right here. And what I would do is I would take 157. I would subtract the 37 and half of that. So it's going to equal 1/2 of 57 minus 37. Which when I take that, that's 1/2 of 120, which would equal 60 degrees. And yes, I'm doing very simple examples here. Tomorrow, or when you get your skills practice, they might be a little more tricky than this. Remember, they can throw some algebra in here. This could be like 2x. This could be, they could throw some other things in there. So just be careful. If I give you the measure of this angle, you could solve for this angle out here. Any of these can be variables. So make sure you practice all the different ways that they give this. So if they ask me for this angle right here, which again would be angle GFK. Remember, F has to be in the center because it's the vertex. It would be, and now this is the one where I was talking about. This is a tangent, and this is a tangent. And since they're both tangent, notice this is 100, and this is 260 degrees. And if I want to label that arc, just to give you a reminder, this arc right here would be called KG arc, and it's allowed to be a minor arc because it's under 180 degrees. And then we've got this one right here, which is a major arc. In order for me to be able to label that, I would call that KHG arc. And if I wanted to label the circle, this would be called circle L. Or you can do a little circle L. Remember, you name the circle by its center. Some of those things just to go over. So in this one, I would take 1/2 of 260 minus 100. And if I did that, I get 1/2 of 160, which would be 80 degrees. And that would be the measure of that angle right there. All right, tangent to a circle theorem says if I've got a radius right here, which I know is the radius because it goes from the center to the exterior, and I have a tangent line. Those two intersect at this point right here. I know that that forms a 90-degree angle. That's what this tangent to the circle theorem states. All right, so I put these were in your book. It's on page 873, so if you want to go to that page, you can pause the video real quick and go to that. I just went through this example. There's some big numbers in here, so I just kind of copied and pasted what they had. I'll explain it through this. We know that this right here, we know that when she's looking out, she's going to look at the horizon, and as soon as the curve of the earth is too much, her line of sight is no longer going to be able to see over that. So I know that this sight is going to be tangent to the circle, to the Earth's curvature. So she's standing over the top. She's looking out over here. This is her line of sight. And it's going to be tangent to the Earth. And then I have this right here, which is the radius of the Earth. And so basically from my theorem last time, I know that that makes that a right angle. And since I know that that's a right angle, and I know that this is a three-sided figure, I know I have a right triangle. And when I have a right triangle, a squared plus b squared equals c squared is still coming back to us. And so I can go ahead and use that triangle that I see appearing, and I fill in some information. She says that she's standing on top of Mount Everest, which is this high, 29 feet. And her eyes are 5 feet above ground. The radius of the Earth is approximately this long. So if I wanted this, right, across from the 90, this measurement right here is going to be my C value. That is the one that I care about, at least making sure that I understand that. Before I can go ahead and do some of this, I have to do a conversion. They wanted to turn this into miles because everything else was in miles. You can see that the Earth's radius is in miles. So they first turned the elevation into miles, and the way you do that is you put 1 mile over 5,280 feet. The feet actually cancel out because this is like over 1, and then when I multiply that, I get that that's about 5.5 miles. So then they go ahead and they say this right here, this is A, this is B, and this is C. So if I look at that, need to be very careful with this one, because the length right here is the radius of the Earth, which is 3,960, and that's going to be one of my legs. So that's either going to be A or B, I don't care. And then this is going to be B, but I don't know that length, so that's going to be my unknown. That's why they have HM right here. That's that unknown value, and it's squared. Now this value right here, where did they come up with that? Well, if you look at this, from here to here is the radius of the Earth, but from here up is how high she is. So you actually had to take that 3,960, which is the radius of the Earth, to the center of the Earth, and then you had to add the 5.5 miles she is up in the air because she's on the mountain, and that would actually be our C value. Then the rest is just a plug and chug, just doing some math as far as adding. So they added these two together and squared it, and that's where they got this number from. They just took this number and squared it and calculated and got this. You then subtract this from both sides, so they minused it to this side right here and got this number. They got rid of the square by square rooting, and they square rooted that, and they got this answer right here. Hopefully I explained that pretty well, thoroughly for you. If you have questions, you can see me about that. Next one, again, is in your book. You can go ahead and try this one on your own. These are called like concentric circles because they're circles that have the same center. And so what happens here is, because I know this, they want me to figure out what is RT. They want me to figure out what is this right here. And the way that I can figure that out is I can say, okay, I know that this angle, I can figure out this angle right here. The way that I can figure out this angle right here is I know that any exterior, I'm sorry, that's not an exterior. On this one, you got to be careful. On this one, if I kind of, with my mind, erase this middle circle, hopefully you see that this is an angle that is called, what we called a inscribed angle. That is inscribed to the large circle. We are only dealing with what is in blue right now. Let the black go away. So right there, you can see that this is inscribed. And since I know this is 86, I know that this is half of that. So I know that that is going to be, that angle is going to be 43 degrees. That's what they got right here. That's where they got that 43 from. Because this is inscribed, this angle is 43. Now, if I know this is 43, then I can fill in, and I know that 43 degrees has to equal 1/2 of some number. And since if I look at now, I redraw this and I look at this and I've got this thing going on. I've got the little circle and I've got this angle that's appearing outside of it. And I know that this angle right here is 43 degrees. And I know that this measurement right here is 21 degrees. And I want to find this one. That's my question mark. What is this one? What is the measure of that arc? So I know that now I've got to combine. Now I've got to use this, my new theorem, which says, hey, since this is exterior, I know it's 1/2 of unknown minus 21. And then how we get rid of that is we undo this stuff. So we multiply by 2 to get rid of the half. Multiply by 2 to get 86 equals x minus 21. add 21, and you get 107 is the measure of that arc. So hopefully that that makes sense to you. Again, if you have questions, make sure you see me tomorrow on any of this. Next one again is going to be in your book, page 875. This time they want us to figure out the measurement of each one of these angles. So since I know this is 120, since I know this is 105, I can figure out angle 1 or angle 3. It doesn't matter which one I do first. And the way that I figured that out is they did it right here. They said 1/2 of 120 plus 105. Remember, that's that theorem. So this is an interior angle. You add this plus this, and take half of it, and you got that. Because this is 112, we already talked about that. This is going to be a vertical, so you know that the measure of 3 is the same thing as that. And the way that they figured out what angle 2 is you know that 1 plus 2, those two have to equal 180 because they're a linear pair. So they took 180, subtracted that 112.5, and they got that 67. If I know this is 67.5, this also has to be 67.5. Again, because we have that vertical angle here going on. All right, last one. Again, this is on page 876. The last couple have been in your book. You can go and look at those and try them on your own. If you want to pause this and try it on your own first, that'd be great. So they want me to figure out, determine CD. They want me to figure out what is this right here. Well, again, in order for me to do that, I'm going to need to know this angle right here or this angle, which I don't know. But I do know that this angle right here is 80 degrees. And since I know that's 80, I know this plus this has to be 180 because they make a straight line. So I know that has to be 100 degrees. That's where they got this 100 degrees. And then I know 100 would equal 1/2 of 88. And this one will be plus CD arc. And the reason that it's plus is because this is an interior angle. Again, do the same kind of stuff. Undo algebra, times by 2, times by 2. 200 equals 88. You can drop those parentheses now. 88 plus my unknown, which is arc CD, minus 88, minus 88. And that's where they got 112 degrees as the measure of arc CD. So those are all the kind of examples they can come up with. Please make sure you take those notes. You can write in your book if you want to. If you wanted to pause some of them and try them again, it'd be great to go through some of these. Have a great night, guys, and I will see you next time.